Okay, hello everyone. Welcome to Physics Academy. Okay, in the last 6 videos, we basically covers the Jest 2024 MCQ 1 marks questions, MCQ 3 marks questions. Okay, and this is the last part of our Jest 2024 PIQ series, and in this video, I will cover total NAT type questions. Okay, 10 NAT type questions, and each NAT type questions have weightage 3 marks. Okay, so this video is the last video for Jest 2024 PIQ series. Okay, and after that we will continue for 2023 PIQ series. But before that paper, first of all, I will provide you a important videos. What is the important videos? The important videos is I'll give you some important topics, some advanced topics, theoretical descriptions also. That's why you will cover, or you will understand in a better way the advanced topics also, which are asked in 2024 examinations in your questions paper. Okay, so this is our styles. Actually, I will complete the all PIQ for each and every questions for a particular year. Then I will give you the details, theoretical descriptions of the advanced topics. Okay, actually Jest examinations have a common questions for BSc students as well as for MSc students, but those are pursuing MSc students, they already know the advanced topics like group theory, rotational matrix formula, perturbation theory, okay, and WKB approximations, etc. This type of advanced topics asked in your exam question paper. But who are pursuing BSc first year, BSc third year, okay, recently they complete their JAM examinations. I hope all you're doing it better. Okay, so don't if anyone feel my exam is not good, don't worry, focus on next exam like CUCET and Jest examinations. So from IIT exam to the Jest examinations, there is a huge gap, approximately 60 days. So you utilize these 60 days in proper way and you definitely give a better exams. Okay, so don't worry. So today we'll discuss the last 10 NAT type questions for Jest 2024. Okay, so let's start our video. Okay, my name is so as usual, my name is Mithun Patro. I am a PhD student at ACPS NISETS. I'm actually working in exoplanetary atmosphere for theoretical and JWST observations of exoplanet atmosphere. Very exciting topics. You all know who are actually interested in planetary science or astronomy, astrophysics. So this topics is a very emerging field. Okay, so don't worry. Your first priority to clear the all exam in good way, right? So okay, let's start our video. So this is the first questions of NAT type questions paper. This is the first questions for NAT type questions paper. Okay, so a system of two non-interacting identical bosons is in thermal equilibrium at temperature T. The particles can be in one of three states with non-degenerate energy eigenvalue minus epsilon, 0 and plus epsilon. Okay, and the temperature T, and such that exponential minus epsilon upon kB is equals to half, it's a given value, and where kB is the Boltzmann constant, the average energy of the system is found to be minus n upon 35 epsilon, where n is integer. What is the value of n? So basically here given three energy states. Okay, minus epsilon, non-degenerate energy state, 0 and epsilon, and number of bosons. Here number of bosons is given is 2. So number of boson is given is 2. So first of all we distribute these two bosons for each and every energy state, and then we find out the total energy. As we know, the properties of bosons, what is the properties of bosons? Bosons, there is no restrictions to occupy the number of number of bosons in a particular states. I means a bosons in a states occupy large number of more than one. Also, a one bosons also placed in a particular states. So there is no restriction to place the bosons in a particular states. Okay, I will put one bosons, also I will put more than one bosons for a particular state. So there is no restrictions as like fermions, right? And all the bosons are actually identicals, so it's a very important properties for bosons also. So what is the properties, bosons, what is the properties, please write down. Bosons, for bosons there have no restrictions to occupy in a particular states. This is the properties of bosons. There have no restrictions to occupy bosons in a particular state, in a particular state. Properties number 2, bosons are identical. Okay, these two are the properties for bosons. Now we distribute these two bosons in proper way. This is the energy level diagram. So first of all, we place two bosons in minus epsilon state, and then the total energy minus 2 epsilon. Okay, then we place two bosons for 0 energy state, then total energy is 0. Then again we put two bosons in plus epsilon state, then we get total energy 2 epsilon. Then another combination is one boson place its minus epsilon, one boson places 0 energy state. So total energy is actually minus epsilon. In the similar way, one boson is placed is minus epsilon, another boson is placed is plus epsilon energy state. So total energy is actually 0. Total energy is actually 0. And again one boson places 0 energy state, and or another boson placed is plus epsilon state. So total energy is plus epsilon. So these are the total energy. So there have been no degeneracy. Right? So we get here, first of all, we distribute the two bosons in 3 energy state, non-degenerate energy state, and we find out the total energy, corresponding total energy. Okay, now we calculate the partition function of the systems. Okay, so this is the partition function formula. We already know this is the partition function formula. Z equals to summations over I e to the power minus beta epsilon I, and here epsilon I is the total energy, and this epsilon I are actually, these are the epsilon I. These all are actually epsilon I. Okay, so each and epsilon I we place here. So first of all, epsilon I is equals to minus 2 epsilon we put here. So that is equals to e to the power 2 epsilon upon kt plus e to the power minus 2 epsilon upon kt plus e to the power minus epsilon upon kt plus e to the power plus epsilon upon kt plus 2. Why is 2? Because 0 energy state is 2. This is the 2 energy state. There will be degeneracy, right? There will be degeneracy. So that's why 2 is placed here. That's why 2 is placed over 2 into by 0. So finally we get the partition function z equals to 2 e to the power 2 epsilon upon kt plus e to the power minus 2 epsilon upon kt plus e to the power minus epsilon upon kt plus e to the power plus epsilon upon kt. So this is the partition functions. This is the partition functions of the system. Now we calculate the average energy. So we already know the formula of average energy. If you know the partition functions, this is the formula of average energy, summation over epsilon I e to the power epsilon I kt upon partition functions. So let's this is the energy of particular energy state, total energy state. So first energy is 2 epsilon, so that is equals to 2 epsilon e to the power minus 2 epsilon upon kt. Next energy is epsilon e to the power minus epsilon upon kt. Next energy is plus minus 2 epsilon e to the power plus 2 epsilon upon kt, and minus epsilon plus epsilon upon kT and plus 0, these two energy states. Okay, and this is the partition functions. Next we get here given e to the power minus epsilon upon kT is equals to half. Okay, epsilon upon e to the power epsilon upon kT, this is given actually, right? This is given. We use this value. So after using this value we get 2 epsilon upon 4 epsilon upon 2 minus 8 epsilon and minus 2 epsilon. And for the partition functions also we get this value, this type of value. Just calculate, very easy. So finally we take epsilon is common, so finally we get in the numerator we get minus 9 and in the denominator we get 35 upon 4. Okay, 35 upon 4. So finally we get, this is the answer, minus 36 upon 35 epsilon naught. So finally we get the average energy for this case 36 upon 35 into epsilon. Okay, this is the average energy for this system. So after comparing this, so we get the value of n is actually 36. The value of n is equals to 36. So this is very easy question, just to calculate. So for that type of questions, first of all we need to distribute the particle each and every energy state and we calculate total energy, and with respect to this total energy we calculate the partition functions also, and then we calculate the average energy, that is the formula. We use these formulas also. Okay, and we use this the mathematical value and we get this results. Average energy minus 36 upon 35 epsilon. So this is a very easy problem. So you just focus the step, right? You just focus the step. How can I calculate and how can I deal with each and every problems here? Okay, this is the question number 36 for first questions. Next we go to question number 2. Okay, what is the questions? Questions is a semi-infinite, that's very important, semi-infinite. Okay, the semi-infinite thin wire extending from minus infinity to 0 along the z axis and carries a constant current I. Okay, carries a constant current throughout the wire, carries a constant current I in the positive z directions. Okay, the wire is charge neutral except at z equals to 0. The wire is charge neutral except at z equals to 0, where the inflowing charge is accumulated. Okay, at z equals to 0, inflowing charge is accumulated. Charge is actually accumulated at z equals to 0, right? Charge at point is accumulated charges at z equals to 0, right? It means charge are actually rest. All charge are rest. When charge are rest, they not create magnetic field. So here, due to this charge, we are not get any kind of magnetic field. This is the concept. Please remember, as all the charge are accumulated at z equals to 0 point, hence for this charge we are not get any kind of magnetic field. We get magnetic field only due to the current that is flowing along positive z directions throughout the wire. Okay, that is the question. And so what is the absolute value of this integral? So you just calculate the absolute value of the integral along the circle x square plus y square equals to 1, where b is the magnetic field, m is the permittivity in the free space, assuming that the accumulated charge at z equals to 0 is a point charge. Okay, yes, assuming that the accumulated charge is z equals to 0 is a point charge. So for this point charge we are not get any kind of magnetic field because all the charge are in rest. When charge are moving, then created magnetic field, right? Okay, we just calculate the magnetic field. So we apply first of all, to calculate this integral, we apply the Ampere's law. What is the Ampere's law? Ampere's law, integrations b dot dl equals to mu 0 I enclosed. I enclosed is nothing but the net current enclosed by the closed loop, right? Net current enclosed by the closed loop. Okay, so a fully infinite wire would contribute I in the, right, a fully infinite wire would contribute I in the positive z directions. Okay, in the positive z direction already mentioned in questions. But however, only half of an infinite wire. However, only half of the infinite wire is present. That is because minus z equals to minus infinity to z, that is actually present. So by symmetry, the enclosed current is only half of that of the fully infinite wire. So actually लूप एक टोटल लूप हम लोग एज्यूम किया एम्पिरिकल लूप, उस एम्पिरिकल लूप के अंदर फुल इनफाइनाइट वायर से एक्चुअली हाफ वायर माइनस z2 is actually present. So from this symmetry, this loop is the enclosed current, the enclosed current enclosed by this loop is actually half of the total current. Okay, this is the symmetry from the symmetry problem. So I enclosed is equals to I upon 2. So finally we get I enclosed. So B dot integrations B dot dl equals to mu 0 I by 2, because I by 2 is the I enclosed total enclosed current in empirical loop, right? This is actually enclosed current in a empirical loop. Okay, so finally we get B dot dl equals to mu 0 I by 2. Now in our questions they ask find out the integral 4 upon mu 0 I integrations B dot dl. So that is equals to 4 upon mu 0 I into mu 0 I. Mu 0 I cancel each other, so 4 upon 2, this is the answer is 2. So finally we get the integrations of this integral is equals to 2. So that is actually asked from the empirical law. Next, that is very important question. This is the advanced topic. Okay, for this advanced topics I will give you the details theoretical video for rotational matrix and how to calculate the trace of an rotational matrix. How can I get this formula? This is very important. So you just remember, for a rotational matrix the trace formula is like that. Okay, so don't worry, first of all you read the questions, and in a next video I'll give this I'll give for a specific video for the advanced topics. What are the advanced topics they ask in Jest 2024? Okay, right? So consider the rotation matrix. This is the rotation matrix, and let phi be the angle of rotations. And what is the value of this sec square phi? Right. So we use the trace formula of rotation matrix. This is the formula of trace formula of rotation matrix is equals to 1 plus 2 cos phi. Always the trace formula of rotation matrix. So for a trace of any kind of matrix is equals to summation of diagonal element, right? So that is equals to 2 upon 3 plus 2 upon 3 plus 2 upon 3 equals to 1 plus 2 cos phi. Okay, so that is 1 plus cos 2 phi equals to 2. So 2 cos phi equals to 1. So cos phi equals to half, and 6 phi equals to 2. So that is equals to sec square phi equals to 4. So finally you get the answer. So this is the very easy question. You know, for advanced topics they always ask them very easy questions. So if anyone not aware about this formula, so they not attempt to they are not trying to solve that type of questions, right? So if anyone know this formula, so he will get 3 marks in very minimum effort, right? So he will get the 3 marks in by 3 minimum effort, right? So for me advanced topics, most of the questions are very easy. So to get 3 marks we need minimum effort, right? So these are the questions. Minimum effort questions. These all are minimum effort questions. Okay, So advanced, so don't panic, we are not cover advanced topic. Please cover all the advanced topics. You just download the syllabus and complete the all advanced topics from this syllabus. They ask most of the time in your examination very easy questions from the advanced topics. So that's like that. So use the trace formula of rotation matrix. Please make a note in your copy what is the trace formula of rotation matrix, right? Trace formula of rotation matrix is equals to 1 plus 2 cos phi. So this is the question and its answer. Question number 4 is very important, easy questions, and that question is asked from this harmonic oscillator. A quantum harmonic oscillator of mass m and angular frequency omega is in the state and ket n denote the nth normalized energy eigenstate of the harmonic oscillator, and let L0 equals to h cut upon root under h cut upon m omega denote the oscillator size, okay, and expectations value of x cap denote the expectations value of the positions operator in the state psi. So what is the value of expectations value of x upon L0? You may use the form of positions operator in terms of raising and lowering operator, that is already given. So okay, it's a very easy questions. These are very easy questions. So this is the given state. So now we try to find out the expectations value of x is equals to brass psi x cap ket psi. So we just rearrange this. So half is basically occurs from 1 by root 2 into 1 by root 2. So that is equals to plus 287 plus 288 into x cap ket another state. This is the another state. So this is the actually complex conjugate of psi ket state, and this is the ket psi state. So after rearranging all the terms, we get this six terms. Okay, this 6 terms. So from these 6 terms, first 2 terms are actually 0 because they follow the orthogonality conditions. So that's why these 2 terms are 0. So now the remaining terms are so now use the remaining terms. Now we put here the value of x cap. Now put here the x cap. So x cap is equals to nothing but L0 upon root 2 a cap plus a cap dagger. We just put here okay, we just put here so here we get L0 upon 2 root 2. These are the each and every component. We just make a note, right? We just make a note each and every component. So now we calculate from this first terms. We use this formula when a lowering operator acting on ket n, that is equals to root n minus 1 ket, and also okay, and for that for the second part we use the formula a cap dagger n cap is equal to root under n plus 1 ket n plus 1, and for all other expectations value we use this lowering and raising operator formula, right? So after applying those formulas, we get is equals to root under 288 is equals to 287, the scalar multiplications of 287, and for this next part we get 289, and the scalar multiplications between two state 287 and 289, and for third part we get root under 287 is equals to scalar multiplications between two state 288 and 286, and for last part we get root under 288 equals to scalar multiplications between 288 and 288. So from the orthogonality conditions, these two values are equals to 0 because they are different state, right? And these two values have 1. So finally we get L0 upon 2 root 2 is equals to root under 288 plus root under 288. Okay, so that is equals to, so so the derivative 2 value and the derivative 2 value, so that is equals to 2 into 288. So these two is cancel each other. So finally we get L0 upon root 2, L0 upon root 2 root under 288. So we know the root under 288 value, you just use your calculator. Okay, that is equals to 16.9705, L0 upon root 2 16.905, and after that we get L0 equals to 11.99, that is equals to 12 L0. So we get, finally we get, this is the value of expectations value of x cap is equals to 12 L0, right? So now they ask what is the value of this expectation value of x upon L0 equals to L0 upon L0 into 12. So L0 L0 cancel each other, so finally we get 12. So this question is very easy, right? We just use this lowering and raising operator acting on nth state. What is the gate? This is the concept actually they ask, that type of questions they ask. Okay, question number 5. I'm very sorry, I will try many times to solve these questions, but I am failed. Okay, so I will try to solve these questions. If anyone solve it, please send me the solutions. Okay, I will also try to learn that type of integrations, because the integrations of ln x is very difficult in analytically. So it's very easy to solve this type of integrations by numerical way. So analytically solved by this type of this type of functions is very hard. This is, so that's why I'll skip these questions. Okay, that's why I'll skip this question, because here we get a part, that is the integrations of ln x, ln of 1 minus integration of this type of functions. Actually, so the integration of that type of functions is solved by analytically is very difficult. So that type of integration is basically solved by numerically, like Simpson one-third method, trapezoidal methods. So it is not hard, but in analytical way it is very difficult to solve that. So that's why I skip these questions. Okay, so okay, again I'm sorry. Now we go to the question number 6. Question number 6. What is that? Questions number 6. A point mass m, constant to move along x-axis, is under the influence of gravitational attractions from 2 particles, each of mass capital M, fixed at 2 points x equals to 0, y equals to a, and x equals to 0, y equals to minus a. Find the time period of small oscillations of the mass m in units of pi root under a cube upon 8 gm, where g is the universal constant. So this is the diagram. So the two mass are fixed at this point, at this point, at these points, and here is small mass m that is actually moving along x directions. So let us consider at a particular time, particular positions, the point mass m is located at x equals to x0, at x0. Okay, now the distance between capital M and small m is equal to root under x square plus s square for two cases also, right? So over each fixed mass m exerted a gravitational force on small m, that is equals to capital F g m upon r square, and r is actually root under x square plus s square, so that is equals to g m upon x square plus a square, and the force is in the x direction due to one mass. We just calculate along the x directions. This force is along x directions. We multiply with cos theta, that is equals to g upon x square s square equals to cos theta. Okay, cos theta, and we get the value of cos theta from this geometry. You just calculate, very easy. This part is very easy. That is equals to cos theta equals to x upon root under x square plus a square. So finally we get g upon x square plus a square 3 by 2 x. Now for two mass symmetrically placed, we know these two masses are symmetrically placed, so total force in x direction is equals to 2 into g mmx upon x square plus s square 3 by 2. Okay, now for small oscillation we apply here approximations, x very less than a. Now the denominator term x square plus s square whole to the power 3 by 2 is equals to a cube plus 1 plus 3x square upon a square, but here a is very large compared to x, that's why this term is negligible. We get this is equals to a cube. So the total force acting on small m by this two mass, capital M mass, are equals to minus 2g mx upon a cube. Now the equation of motion of this small mass is equals to m d2x upon dt square equals to capital total force acting on these, that is equals to minus 2g capital M small m a cube upon x. So mm is cancel each other, so d2x upon dx square equals to minus 2g m upon a cube into x. Okay, so that is equals to d2x upon dt square equals to plus omega square x equals to 0. This is the actual equation of motions. So from this equation of motions, angular frequency omega square equals to root under 2gm upon a cube. So omega equals to root under 2gm upon a cube. Now the time period of oscillation is given by 2 pi by omega, that is equals to 2 pi equals to root under a cube upon 2gm. Now we match with the unit basically mentioned in the questions, that is equals to, for this course, for that we multiply it with 2. Then multiply it with 2, we get 4 pi and root under a cube upon 8gm. So from this unit, this is the unit actually. They ask what is the time period in the unit of that, right? That is equals to 4. So the required answer is 4. So from this question is very easy question, that is class. Okay, that's very BSc level questions. Right, this is BSc level questions. Okay, next questions from hydrogen atom problem, question number 7. Now the radial part of the electronic ground state wave functions of the hydrogen atom is given as. So this is equals to actually RNL. Okay, so n equals to 0, L equals to 0 for ground state. The ground state eigenfunctions is given. A0 equals to Bohr radius. If expectations value of r and rmp denote the expectations value of r and maximum value of this radial coordinate, then respectively compute this term. Okay, so we know the expectations value for NL state is equals to, this is the formula actually, please remember this formula, please remember this formula, half 3n square minus L into L plus 1 equals to A0 is the Bohr radius. So here for ground state n equals to 1 and L equals to 0, that's so I put this value. So expectation value of R is equals to 3 by 2 A0. Now the most probable value radial coordinate, please remember this formula also, most probable value is equals to n square 0 for all case, for any order of state. Most probable value of n radial coordinate is equals to n square 0. Please remember also. Okay, so n equals to 1, so rmp is equals to a0. So finally we get 8 upon 3 expectations value of r upon rmp. We just substitute these two value, 8 upon 3, 3 by 2, a0 upon a0, a0 0 cancel each other, so 3 cancel each other, so that is equals to 2, 8 cancel 4, so answer is 4. Okay, so that's very easy question. So if for, so please remember this two formula is very important. These two formulas is very important. Expectations value of r for nth state, expectations most probable value of radial coordinate. Please remember, most of the time asks that type of questions from hydrogen atom problem. Next question is question number 8. Okay, question number 8. A magnetic vector potential A is given as, find the corresponding outgoing magnetic flux through the 5 phases excluding the shaded one of unit cube, one corner at the origin as shown in the figure. Okay, so this is the given magnetic vector potential. So in the outgoing magnetic flux through a surface is given by closed surface integrations B dot ds. So here we apply the divergence theorem, that is equals to divergence of B equals to volume integrals. So now from magnetic vector potential we calculate magnetic field is equals to curl of A, B equals to curl of A. So from these expressions, just solve the very simple mathematical formula. So we get magnetic field B equals to 3 minus 2yz I cap. So divergence of B equals to 0 because there is no x component. So as divergence of B is 0, so from this equations 1, so flux outgoing flux is equals to closed surface integration B dot ds, volume integration divergence of B equals to dV. So as divergence of B equals to 0, so we get flux equals to 0. So outgoing flux equals to already 0. Okay, for the all 5 state, 5 phases. That is very easy questions asked in your examination. That is also BSc level questions. Now question number 9. An interaction semiconductor at 300 Kelvin, the number density of electron is any, is have a given value, and if the mobility of electrons and the mobility of holes are also given, find the conductivity in units of mho per meter. So charge of electron is given. So we know the conductivity of a semiconductor have a formula, sigma equals to ENE mu E plus ENH mu H, where N is the electron density, NH is the hole density, mu is the electron mobility, mu is the hole mobility. Okay, so for intrinsic semiconductor, the electron density or hole density are actually equals. Okay, so now we use this formula in equation number 1. So now hence the conductivity for intrinsic semiconductor, okay, that is equals to sigma ENE mu E upon mu H. Okay, now we just substitute all the value and we get the final answer is equals to 24 mho per meter. So it is very easy questions also. This is also from BSc level question. So you know, if your BSc syllabus is very strong, so definitely clear the exam. It's the last questions of Jest 2024. You know, we are covered the total 50 questions, right? So an object of height 10 millimeter is located at 150 millimeter to the left of a thin lens of focal length plus 50 millimeter. Okay, and the second thin lens of focal length minus 100 millimeter is to be placed to the right of the first lens, okay, such that the real image of the object is located 100 millimeter to the right of the second lens. Okay, so what should be the separations in millimeter between the two lenses? So first of all, here the geometry of lens systems. So this is the lens 1 and this is the lens 2, and here the first object is actually present. Object is present at a distance t0, and this lens have a focal length f is equals to 50 millimeter. So for this first lens we get object at a distance di, image, we get image at a distance di. Okay, and we also consider the separation between these two lenses is equals to d. That is the separation between two thin lenses, and from this second lens at a distance di prime we get actually image, and this lens have a focal length minus 100. So in the question they ask what is the value of d. Okay, so from this geometrical view or geometrical representations, here di plus d0 prime is equals to actually d. So d0 prime is equals to d minus di. So to solve these questions, first of all we need to calculate what is the image distance formed by first planes, that is di. First need to calculate the value of di. So from the thin lens formula, for the first lens 1 by f is equals to 1 by d0 plus di. F is the focal length of the first lens, d0 the object distance for the first lens, di is the image distance for the first lens. Okay, f is equals to plus 15 millimeter, d0 the image distance, object distance is equals to 150 millimeter, and we first calculate the image distance formed by first lens. So we just substitute all the value and we get the image distance of the first lens is equals to 75 millimeter. Okay, and next we apply similar way the lens formula for this second lens. So 1 by f prime is equals to 1 by d0 prime plus 1 by di prime. Okay, this is the di prime, and d0 primes is equals to d minus, not di, that is equals to di, not d0, this is equals to di actually. Okay, please see the mistakes, di. So 1 by f is equals to 1 by 100, so di is equals to 75, we substitute here. So from these expressions we easily calculate 1 by d minus 75 equals to minus 2 by 100, so d minus 75 equals to minus 15, so d equals to 25 millimeters. Okay, so that type of questions in IIT JAM examinations most of the time they ask many times they ask that type of questions in different ways. Lens maker formula, thin lens problems, right? So I hope that type of questions are important for your Jest examination, right? So thin lens formula is very important for IIT JAM, also CUCET examinations, also for the Jest examinations. So please cover these topics, is very important. So finally we complete Jest 2024 all PIQ, right? Next video, in the next video I will upload based on the advanced topic which are actually asked in Jest 2024 PIQ, because that is very important to understand in better way what is the actual theory of the advanced topics. You know, in Jest 2024 less number of questions they ask from advanced topics. Most of the questions they ask from the basic topics, core topics, right? From the BSc level topics, basically from your IIT JAM syllabus, but they ask in but the approach but the calculations are lengthy. You know, in Jest examinations all and every questions are lengthy, right? So in Jest examinations your calculations ability is very important. If your calculation skill is very poor, then please improve your calculation skill within 2 months, otherwise you not qualify your Jest exams, right? So please improve your calculation skill, please improve your strong concept, and also cover all the syllabus related to PIQ. Okay, and please complete all PIQ. Okay, and in my channel I will complete all the PIQ and all the advanced topics they ask in Jest examinations before your examination. सॉरी, आपके एग्ज़ाम से पहले हम सारे PIQ और जितना सारा एडवांस टॉपिक्स है सारे एडवांस टॉपिक को हम कंप्लीट करने का कोशिश करेंगे, ठीक है। और आई होप ये जो जेस्ट 2024 का सारे PIQ का जो सॉल्यूशंस है ये आपके बहुत ही यूजफुल होने वाला है ना। और अगर इस जेस्ट 2024 में से किसी भी क्वेश्चंस का आपको इफ़ एनी क्वेश्चंस इफ़ यू फील डिफ़िकल्टी टू अंडरस्टैंड, प्लीज़ comment in my channel. Okay, I'll make a separate video for those particular topics which are very important, like theory discussions, and after that you definitely solve the problems, or definitely understand what is the concept behind the problems. Okay, so I hope you enjoy the sessions for just 2024 series, राइट। जो जितना सारा 50 क्वेश्चन था, सारे 50 क्वेश्चंस को हम लोग सॉल्व किया इन प्रॉपर वे। सारे 50 क्वेश्चंस को हम लोग सॉल्व किया इन प्रॉपर वे। सो मेरे हिसाब से आपको बहुत ही बेनिफिट को मिला होगा। इतना सारा PIQ था वो मैंने सॉल्व तो कर दिया, आप लोग भी खुद से सॉल्व करिए। और मैं एक वीडियो में को डाल दूँगा, आई विल अपलोड ए वीडियो बेस्ड ऑन टॉपिक्स एट वर्ड टू टॉपिक्स दे आस्क इन जेस्ट 2024 questions. Okay, so that is very useful, right? These videos are useful to revise your syllabus from PIQ. Okay, so you solve first PIQ, all the PIQ of just 2024 from my YouTube video. Then please revisit the particular theory section for particular sections and complete all the theory in proper way. Okay, and third, if you feel any kind of difficulty to solve, difficulty to understand the theory, please comment in my channel. I will give the solutions. Okay, I will give the solutions. So okay, so for today, thank you for watching all the videos, and I hope it is your responsibility to cover all the videos, because if you go through all the video, right, then you see I will try to explain all the problems in proper way, in details. Okay, in details. That's why I will first write all the solutions, all the important concept, because my aim in a short interval of times give you the maximum to maximum solutions, right? Rather than actually what is my approach, actually it is the which approach I actually follow in whole जेस्ट 2024 PIQ सीरीज, वो मेरा एक्चुअली अप्रोच ही नहीं है, ठीक है। वो मेरा एक्चुअली अप्रोच ही नहीं है। मेरा अप्रोच क्या था, मैं जस्ट सॉल्व कराना है क्लास में बैठ के, जैसा होता है पहले से सॉल्व करके रखना नहीं है, ऐसा नहीं है। ऐसा मेरा अप्रोच नहीं है। मेरा अप्रोच एक्चुअली था तुरंत ही सॉल्व करना। बट मैंने सोचा जो टाइम इंटरवल है, इस कम टाइम इंटरवल में आपको एक 40 मिनट में आपको ज़्यादा से ज़्यादा मैक्सिमम से मैक्सिमम सॉल्यूशन मिलना चाहिए आपको। इसीलिए मैंने क्या किया, सारे PIQs का जो सॉल्यूशंस है, सारे PIQ सॉल्यूशंस को मैंने लिखा पहले, उसके बाद मैंने एक्सप्लेन किया, जो इंपॉर्टेंट पॉइंट्स है वो मैंने एक्सप्लेन किया, ठीक है। इसका जो होल PDF मैंने लास्ट वीडियो में जो मेरा जो टेलीग्राम चैनल है, ठीक है, उस टेलीग्राम चैनल में इसका वीडियो का PDF का लिंक मैं आज शेयर कर दूंगा, जिसमें सारे 50 क्वेश्चन है, ठीक है। तो ये सबको, अगर आपको इसको देखना है, आप जो स्टूडेंट अभी तक टेलीग्राम चैनल में ज्वाइन नहीं किया तो ज्वाइन कर लीजिए, डिस्क्रिप्शन में लिंक है, कोई वक्त नहीं। ये आप लोग का रिस्पॉन्सिबिलिटी, आपको क्या करना है क्या नहीं करना है। मैं तो खुद से नहीं बोलने वाला हूँ, हर बार आप खुद से ज्वाइन कर लीजिए, ठीक है। आपको एक्सप्लोर करना पड़ेगा। सारे वीडियो का लिंक मैं डाल दूँगा, ओके, ठीक है। ओके, थैंक यू for watching this video, and please subscribe, like, and also please share these videos with your friend who are preparing the Jest examinations, right? Okay, thank you.